Good evening. My name is Danae Carlos. I am a research meteorologist at NOAA Research, and I am the policy advisor to Vice Admiral Manson Brown, who is the Assistant Secretary of Commerce for Environmental Observation and Prediction. And I just want to welcome you all to the inaugural Dr. James R. Mahoney Memorial Lecture. I'd like to introduce the NOAA Administrator, the Undersecretary of Commerce for Oceans and Atmosphere, Dr. Catherine Sullivan. Dr. Sullivan was confirmed by the Senate as the Undersecretary of Commerce for Oceans and Atmospheres and NOAA Administrator on March 6, 2014, having served as acting NOAA Administrator since February 28, 2013. She is a distinguished scientist, renowned astronaut, and intrepid explorer. Dr. Sullivan was one of the first 6 women selected to join the NASA Astronaut Corps in 1978 and holds the distinction of being the first American woman to walk in space. She flew on 3 shuttle missions during her 15-year tenure, including the mission that deployed the Hubble Space Telescope. Please welcome Dr. Catherine Sullivan.
So not as tall as Danae Carlos. Well, good evening, everybody, and welcome to this inaugural James Mahoney Lecture here in the Department of Commerce's Hoover Building. I'm delighted to be with you this evening as well. And I want to open by offering a special welcome to arguably the most important people we have in the room with us tonight, a bevy of Jim Mahoney's family, including his daughter Debbie, his sons Jim, Bob, and Peter, a slew of their family, and even several of Jim's grandkids. If any of you have been in this building before, welcome back. For those of you who are here for the first time, welcome, and we're glad you didn't get too lost, and we're delighted to have you with us. I also want to thank the partners who really came together to make this happen, because this evening would not have been possible without the support of our convening partner, the American Meteorological Society, or without the leadership of the AMS Executive Director, Keith Sider, and the Associate Executive Director, Bill Hook, yet another NOAA alumnus who's with us tonight. And finally, added special welcomes to former NOAA Administrator, Vice Admiral Conrad Lautenbacher. Connie, there he is, right in front of me. The members of the Mahoney Lecture Program Committee, Danae Carlos, Barbara Goldsmith, and Keith Sider, our distinguished invited lecturer, Dr. Susan Avery, and all of you who've turned out tonight to honor Jim's memory by way of your attendance. And I feel like we should take a moment of sympathy now for the people who are making their way here through the 5 o'clock DC traffic, or trying to figure out which alleged entrance on 14th Street is actually still a door and can get you into this building. But hopefully more of the folks who had RSVP'd will be able to join us in due course. So in a few moments, Danae will invite Conrad to take the stage and provide some reflections on Jim, including the man he was, the life he led, and the legacy he left behind. And I don't want to steal any of Connie's thunder, but I'd be quite remiss if I didn't use my moments at this podium to take an opportunity to explain how this lecture came about and amplify a bit on its intention to honor a tremendous legacy of service to this agency and to our nation. You know, it's not even a year ago yet that the NOAA family was deeply saddened to learn of Jim's passing. And it was very, very shortly after that that discussions emerged about developing some way to provide a living remembrance of Jim and honor his legacy. And as everyone in this auditorium, I'm sure knows, there's an awful lot to pay tribute to in the way of Jim's contributions to the scientific community. So I want to focus a little bit on Jim the scientist, but particularly through the lens of the tremendous work that he did at NOAA, and with a special focus on his efforts that resulted in him earning the title of Mr. Climate, both within the agency and far beyond our walls. That title didn't come easily for Jim. As Assistant Secretary and Director of the U.S. Climate Change Science Program back in 2002, he came to NOAA and he came into that position against a political backdrop that was fraught with tension around climate science. And he was tasked with jumping right into the middle of all of that and coming up with a strategy that would provide some cohesion and some focus to climate science efforts across the entire federal family. That was a pretty tall order, to say the very least. And Jim was the right guy to do it in every way. Within just 4 years, Jim had pulled together the previously tightly siloed efforts of 13 different agencies into a single coherent global climate change assessment. And anyone who's ever worked in the interagency arena knows how much fun and how dead easy that is, right? Just the word cohesion is just, I don't think it exists in the federal dictionary. But it takes a very special kind of person to bring about that kind of cohesion and to add that degree of clarity to multiple agency efforts. And Jim Mahoney was that special person. I'm sure his Harvard background in public health and the lessons he learned in that arena taught him and gave him clear insights about the really critical need for interdisciplinary approaches, because you can't really advance public health if you're not working across the disciplines. And the same is certainly true in the integrated earth sciences that underpin climate work. Jim knew that weaving together many different scientific disciplines was the only way to move observations into real impact for our communities, from atmospheric sciences to ecosystem sciences to social science and many more disciplines. And today you see that same interdisciplinary approach. It remains to this day a hallmark of today's U.S. Global Change Research Program, and it is a very critical component of much of the work that we undertake across NOAA, and it is an everyday focus at my level and the level of our assistant secretaries and our assistant administrators to continue to look at that high bar of, are we working across all of NOAA? Are we overcoming our own silos? Are we thinking and planning and acting and working the way the planet does or the way the org chart does? Because we need to be working and thinking the way the planet does if we intend to have the kind of service impact for our country that NOAA is charged with doing. You know, among scientists, one's impact on the field can be measured by the sticking power of ideas and of conceptual frameworks or program models that you developed. How well do they endure over time? And just on that metric alone, Jim's legacy is tremendous, and really distinctively so. But for everyone who knew Jim, there is much, much more to his legacy, much more worth remembering than just the foundation he established programmatically and politically for climate research and services. Not to be forgotten was Jim's unique and fabulous style of leadership, one that seemed to enable and propel his success at every turn. Whether he was navigating the intricacies of interagency bureaucracies or negotiating with foreign governments, few who saw Jim in action failed to come away without some really powerful, deep insights about the right, the good, smart, effective ways to lead. He inspired tremendous trust in everyone who worked for him, and he always led by example. He was the model of everything he expected from people around him. He expected things to be done right, and he could be unrelenting in his dedication to doing the right thing. But you know what? That meant that when Jim called, the phone was answered. And it also meant when you called Jim, you got the right answer. You got a solid, trustworthy answer. And it also meant that whenever Jim spoke, in person or over the phone, he did it with what we would call in the Navy a command presence, a real centeredness, a clear, firm but gracious authority that shone through his bearing and his words and how he delivered them. There was always deep and strong conviction in his argument and passion in his message. And that leadership style, this combination of charisma and character and conviction, I think was really the key to the cohesion and the clarity and the momentum that he was able to foster across the agencies in that very difficult time. And I believe it was a combination of that leadership style paired with the programmatic foundation that he built for our nation's climate research and services. I think it was those two things combined that led to people dubbing him Mr. Climate. I think of it much, much less as a nickname and more as an honorific title that his colleagues bestowed on him because of those characteristics and those outcomes that he was able to deliver. But there's one other additional component of his legacy that I would not want to overlook, and I know it will be featured prominently in everyone's remarks here tonight, and that is Jim's unrelenting commitment to mentorship, to developing the next generation. There is a small army today, both around town and across this country, and indeed around the world, of individuals across the weather and climate enterprise who were inspired by his leadership model, challenged by the projects and tasks he gave them, motivated by his success, and really inspired by his personal example. And to Jim, I believe mentoring these individuals, he just did it because it was intrinsically valuable and the right thing to do. It's the way you deal, it's the way you treat people, it's the way you work with people, it's what you pass on to people coming along behind you and with you. Doing good for others just brought him happiness. He was that kind of guy. So ask Asha Tribble, who's now the Deputy Regional Administrator in FEMA Region 9 after a long stint being the climate guru and go-to natural hazards person in the direct circle of the President. Ask Peter Schultz, now at ICF International. Ask Richard Moss, right up there in the middle of the auditorium, who's Senior Scientist at Pacific Northwest National Labs and one of the co-chairs of our current National Climate Assessment Federal Advisory Committee. And from all of these people and many more who I'm sure will be with us tonight, you'll learn about one-on-one moments where Jim came in early or stayed late to help a member of his team overcome a scientific obstacle or suss out how to navigate a complex career decision or a particular political snag. And while each of those relationships and engagements carried intrinsic worth to Jim, the wider value of Jim's mentorship lies in what that has yielded for NOAA as an agency and for the United States Earth System Science and Climate Research enterprise more broadly. NOAA today is filled with countless people who were inspired by Jim, motivated by him, tutored, instructed, and strengthened in their practice by him, and who are eager to build on that foundation, both to deliver on their own service obligation and in many, many ways to pay forward what Jim gave to them in those earlier years. All of those people, all they have achieved so far and all they have yet to achieve, they are also really the living, moving, breathing essence of Jim's legacy. You know, the people that make up a living legacy, united by their inspiration, by the motivation they drew from Jim, by their desire to pay back to him and pay forward to others, they are really the reason that we're all gathered here today. Those of us who knew Jim, for us, there's never been any doubt that we needed to find a way to regularly and richly remember him and celebrate what he did, what he enabled, and the waves of progress that carry on beyond his horizon. His influence on federal climate research and services, his uniquely human style of leadership and everything it gave to us and taught us to carry on in our own leadership practice, and the army of people who remain inspired and energized to this day by his example. So I would offer this hope to our evening today and to all of us here. May this lecture tonight and all that we may hold in years to come, may these lecture events serve that purpose and re-energize and inspire us to the works that are yet ahead, just as Jim used to re-energize and teach and inspire us when we worked with him. So on behalf of the Department of Commerce and the entire NOAA family, again, I welcome you all to the James Mahoney inaugural memorial lecture. I thank you, especially members of the Mahoney family, for coming out to kick this off with us and appreciate your support for this event. We hope you will join us every one of these events whenever it's possible for you to do so. You will always be welcome in the NOAA family. And with that, it's my pleasure to turn the mic back over to Dr. Danae Carlos to carry on with the rest of the evening's program. Thank you very much.
Thank you, Dr. Sullivan. And I know you may have to leave a little bit early because of other NOAA commitments, but thank you for those opening remarks. Next, I would like to introduce Dr. Conrad Lautenbacher. Conrad Lautenbacher, Jr. is retired as Vice Admiral from the U.S. Navy where he was the commander of the U.S. Third Fleet. Admiral Lautenbacher also served as Deputy Chief of Naval Operations in charge of programs and budget. After leaving the Navy, he served as Undersecretary of Commerce for Oceans and Atmosphere and as the 8th Administrator of the National Oceanic and Atmospheric Administration, 2001 to 2008. He is a graduate of the U.S. Naval Academy and holds MS and PhD degrees in applied mathematics from Harvard University. Please welcome Conrad Lautenbacher.
Thank you very much. I'm not as tall as he is either, so I'll lower the microphone. I used to be a lot taller when I was younger, but it's the way it goes. Anyway, it's a great pleasure and a great honor to be with you. And I would say to be with old friends, but I'm getting very sensitive to the word old. So I will say with good friends and colleagues this evening. And thank you for coming and helping us celebrate the memory and the accomplishments of my former deputy. And really, right-hand man, left-hand man, whatever you want to call him, he was there all the time. And I really want to thank everybody who made this possible, Barbara and Susan, who's here, and to give the lecture. And we have Danae, who's done this work, and Manson, and Bill Hook, and we just, enormous numbers of people jumped in to help make this work. And I'm just a guy who's taken advantage of it because I have a great soft spot in my heart for Jim Mahoney. When I first took this job, I was convinced to do it by a gentleman named Sam Bodman, who was the Deputy Secretary of Commerce at the time. And after I agreed to do it after long conversations with my wife, but anyway, so that worked out. But he said, "Oh, that's great." So when I went and told him, he said, now, who are you going to take for your deputy? You've got to have a good deputy. And I said, "Well, I haven't really gotten that far yet." He said, "Well, I have a perfect guy for you." I said, "That's great. Tell me." So he went through Jim Mahoney's background. Sam Bodman was a professor of engineering, or chemical engineering at MIT. And he knew Jim, and he went through an incredible bio. I mean, if you read what Jim has did in his career, it's extraordinary. I mean, he was everywhere. He did government work, he did overseas work, he did private sector work, he was innovative, he was imaginative, he did a lot of things. And so he went through that. I said, Sam said, "Well, I think this would make a good companion for you, a good partner. Looking at your bios, this would be good. You've had a lot of government experience, and he's been out and doing these things." And I thought, this is really great. But one thing came to mind. I've read a lot of too many probably leadership books and management books over the years because of my 40 years in the Navy. So I remember reading one at the time that said, this was a chapter on if you're going to take over something, you're going to be new in a new organization that's new to you. And it were tips from somebody who probably was successful, at least successful enough to write the book that I was reading. And he said, people have trepidation when they go to some new organization. No, was a brand new thing to me at that time. But the tip was, find one person, just start with one person you can trust. And I have to applaud Kathy for bringing up that word trust in her conversation. And so I met with Jim, and we talked for 2 or 3 hours, and a fabulous conversation. And I came away after that, I said, "I've found one person I can trust. This is going to be good. He's the guy." So I went back and told Sam, "Absolutely, let's do that." I wasn't even confirmed yet, or hadn't even been suggested for confirmation to the Senate yet. And so that's how we got started. And thanks to Sam, I'm forever indebted to him for introducing me to Jim Mahoney. And we built, I think, a really solid partnership. Kathy mentioned the political turmoil that goes with climate change, and it's still here today. It hasn't gone away. Jim, I asked him if he would do that, and he said he would, and with a smile on his face and very calm, and he did. He stepped up and started to try to manage 13 agencies doing this kind of work, and all of the press that comes in one side or the other. We were always in some kind of spotlight. Wherever I went, somebody didn't like something I said or something I didn't do, or no matter which side I talked on, I was probably wrong. So at that point, and Jim jumped into that and did a fantastic job. And we developed, I think, a very trusting relationship. I have to mention that there's like a secret passageway that goes between the deputy's office and the no administrator's office. You knock on the door and you can get, you don't have to come around through the corridor. So Jim and I used that a lot. He would knock on the door and say, hey, let me tell you about this, and vice versa. So we had a great relationship in a sense that I really valued his opinions, his experience, and it was just an enormously effective partnership. I don't want to take too long. You've heard a great deal from Kathy, and Kathy summarized a great deal very well. But as I said, I spent 40 years in the Navy, and the core values of the Navy are honor, courage, and commitment. Honor, courage, and commitment. Those are the core values of the Navy. And when you think of Jim Mahoney, that's what you think of. He's an honorable man. There's never a doubt what his purposes were and what he was saying, what he was trying to do. He had courage. He worked both sides, and he would talk to people that I knew he probably didn't want to talk to because of what they believed or how they comported themselves and that sort of thing. And he was committed. I've never seen anyone more committed to something than Jim was. He spent his life, life's blood, literally in his job. And when he came to work for us, he had that bug he picked up overseas a long time ago that he's fought and fought to try to get rid of. But it didn't matter. He worked through it. And the last time I saw him, it was after we were both gone, but I was gone from the NOAA, and it was at the what do you want to call it? The commissioning of the new Weather Service building, National Weather Center, as we call it. We have two now. There's one in Oklahoma, but there's one here. It's all right. And he had to come in a wheelchair, but he came and was still cheerful and interested, energetic, good conversation, and he wanted to be there for that opening, and that was a big deal. And so he did that continuously, and he set an example for people that will be remembered for a long, long time. So before I get teary-eyed, I'm gonna stop. But I was the beneficiary of his. And interesting, I am a partner now in ERT, which is something he invented. One of the things he did along the way as he was excelling in life. So anyway, and here's to you, Jim. Thank you very much.
That's all right. There are people who are movers and shakers, and there are people who are over the hill, and the over the hill people get to introduce the movers and shakers. So I have a great job here. I'm very excited about this for several reasons. I want to start by saying how happy the AMS is to be partnering with the National Oceanic and Atmospheric Administration in the planning for and the execution of this inaugural James R. Mahoney Memorial Lecture. It's a real honor for us. Jim was one of our presidents over the years. He did that in his spare time while he was running NAPAP, which was where he got all the training for dealing with contentious environments. I think climate change looked like a piece of cake to him after that. And we're really happy to be joining with NOAA and with Barbara Goldsmith and sort of making this all possible. Barbara did a lot of work, and the rest of us mainly functioned by saying yes whenever Barbara would call and ask us to do something. So I hope before you leave you have a chance to thank her for what she did to make this day possible. Now, Jim, as we've all heard, was a remarkable human being. And one of the things he would say, one of the things that made him remarkable was that he was interested in science and the application of science for social benefit. So about this time in these proceedings, if he were here, he'd be saying, enough about me. Let's start hearing some cool science from somebody who's actively engaged in that and some cool applications for societal benefit. And any speaker who's invited to honor that memory and legacy ought to fit kind of the Jim Mahoney description. This afternoon, we're very privileged to have Susan Avery give us the first memorial lecture. She just admirably meets this test. So I want to start by giving you a little bit of her resume. You've got some formal remarks in the bio. And one of the first things it says is that she ran Woods Hole. She was the president of the Woods Hole Oceanographic Institution for 7 years, from 2008 to 2015. And most of us would be content to stop there. You'd say, all right, I'm convinced. She's a remarkable person too. But all the admirals here in the front row would be the first to tell you that there are easy tenures in leadership positions like this. And then there's some difficult ones. You can pick the right 7 years and have a smooth ride, or you can pick 7 years that are challenging. And in Susan's case, it was the latter. Let's talk about two things that are part of her legacy there: the internal transformation and strengthening of Woods Hole, making it more robust. And the second part was responding to the historical events that were going on at the time. So if we start with the internal transformation, she arrived at an organization that wanted a new strategic vision. They wanted everything re-examined, from the fiscal and administrative parts to the way they were operating and the kinds of science they were doing, their external relationships, the way they raised money. And so Susan set about doing this. So there were new investments and new starts in marine robotics, in building for ocean observatories and ocean informatics, and also building up intellectual capabilities at Woods Hole in the climate and coastal research areas. She got some major technology initiatives through, including an ocean observatories initiative, design and construction of a replacement for the submersible Alvin, and a new research vessel. Now for some of the things that happened to interrupt or punctuate this tenure, they included the Deepwater Horizon oil spill. That sort of got everybody's attention for a while in 2010. In the same year, the island of Haiti experienced a 7.0 earthquake. Then in 2011, there was a successful search for Air France Flight 447, and also measurement of some of the radionuclides from the Fukushima reactor meltdown. So here are sort of a variety of things that are making things tough. Now at this point, if you haven't known Susan a while, you'd be thinking, well, he hasn't said anything about education, so she must be an oceanographer by training. She must have a whole bunch of research papers in oceanography and all the rest of that. And we know enough about oceanographers and Woods Hole and Scripps and so on to know they don't suffer outsiders particularly gladly. But in fact, her doctorate is in atmospheric science. So she was unburdened in this training by a lot of details about the ocean, and nevertheless, they accepted her as one of their own. You don't have to ask how the tenure went once you hear that an atmospheric scientist ran Woods Hole for 7 years. It didn't just sort of chew her up and spit her out. After getting her PhD, she worked a few years still at the University of Illinois, where she had gotten that degree, but then she came to the University of Colorado, where she spent a big piece of her career. She was on the faculty in the electrical engineering department, a third discipline, for the period 1982 to 2008. And for 11 years of that period, 93 to 2004, she was the director of the Cooperative Institute for Research in the Environmental Sciences. Now, NOAA has a bunch of these cooperative institutes, and sort of early in their history, they were kind of these small boutiques for this or that small research area. But by the time Susan had left, Ceres was something like 400 employees, and she and the Ceres folks had transformed the nature of the relationship between NOAA and academia, and really leveraged the power that NOAA now has to bring to any research or resource problem. In her spare time while doing this, she established K-12 education programs and a Center for Science and Technology Policy Research, and sort of making our science much more accessible to the public. This all got the university's attention. They gave her a lot of interim appointments like Vice Chancellor for Research, Dean of the Graduate School, Provost, Executive Vice Chancellor for Academic Affairs, and so on. Honors and recognition and requests for advice followed. She's going to speak to us today on climate change, the ocean, and us. Join me in welcoming Susan Avery.
Well, thank you very much, Bill. I really appreciate your kind words, and you've been a wonderful mentor. I've had so many mentors throughout my career. Richard Moss is here. The AMS has been a wonderful professional society, as well as the American Geophysical Union. Conrad, great tenure when you were here. So it's been a career that I have no regrets about. And I love the atmosphere. I love the ocean. I love the science. I love what we can do, how we can take science and put it into action. And that's what Jim was about. Was taking the science and putting it into action. I have to get this. You messed up my slides here, Bill. That's okay. They got a sneak preview. Okay. I had the great pleasure of taking a sabbatical leave from the University of Colorado during Jim's tenure on the climate change program here. And with Richard Moss and a team that was absolutely dynamite, I witnessed just sort of this miracle of navigating through a complex, not just the agencies, but the entire political environment surrounding and the skepticism about climate change. And Jim was always firm to the science. He was loyal and true to the science. He didn't care who was speaking. He was loyal and true to the science. And Sam Bodman helped to navigate those political waters. And indeed, Richard Moss, night and day, working on this program, got it through. But in doing it so, it transformed in many ways the USGCRP program. From looking at climate and the big, large climate assessments to taking smaller bites and addressing some really critical questions that people were having in the government at that time about climate. And that came out to a series of numerous assessment reports, which Jim, of course, was quite involved in. And were very, very, I think, influential in paving the way forward for more and more people to begin to accept that the science was robust, that the science was real, and that this is something that we have to address. So I'm gonna, I put up this slide, and I had trouble trying to think what I was going to talk about. I know I spoke to Bill, and I spoke to Richard, and I spoke to a number of other people, Kathy Sullivan, trying to figure out what I could do. And I finally decided to take this approach of climate change, the ocean, and us, humanity, what we're doing, in part because of that, it just was such a central period of Jim's life and my life and the connection with him, focusing on climate. And really try to talk a little bit about sort of my perspectives on what are some outstanding research questions in the climate system. A little bit about the sort of new ways of science interacting with society through policy frameworks. And ending up, since I have a little bit of a bully pulpit here, of what changes I would love to see in our research institutions, in our agencies, going forward after post-Paris Agreement. So I'm going to start with this. And again, I dug deep into the archives, and Richard, you may remember this figure. It was from an old Academy report, and I've changed some of the words on it. But it really shows sort of the interfaces and the pathways, if you will, for connecting science to action. And this is the Science Policy Society interface. And at that center there, at the first sphere here, is understanding this interconnected, and that's the important thing, an interconnected Earth system. This is not just the atmosphere, this is not just the ocean, this is the connection of the atmosphere, the ocean, the sun, the land, the ice, the seafloor, and in fact, life itself, okay? But in understanding that, connecting that science of understanding our Earth system with policy and society interface, it's very important to also bring in this other realm of science, the social sciences, the geographical sciences, the sciences that talk to us about human interaction with our environment, the sciences associated with population pressure, increased land and ocean use, the water and food demands that we have on a growing populated planet, along with the capacity of the water and food demands. The energy demands, urbanization, ecosystem infrastructure, and social resilience, all in a human context where we are polluting the environment, we have climate change issues. And I put geopolitics there because wars and conflict are a great challenge in our world today, and they do affect our environment. But science also has the opportunity here to develop information systems to help plan and manage any number of things. We talk about risk mitigation and resilience, so natural hazard mitigation, looking at human health, and that's certainly the climate change issues and what's happening and the impacts on human health with more intense heat waves. The availability of water resources, not just in terms of quantity, but also in terms of quality. Energy use and development, food availability, again, waste disposal. You get the idea that these are sort of other spheres where science can, with that knowledge that it generates, can develop the information products. And that's what's so good, and what NOAA is working on so hard, what NOAA really wanted to when it tried to do climate services, and it continues to work on developing the information products. I'm just really impressed with the new resiliency kit that NOAA has put together. And then, though, there is the practical actions to live sustainably. This is basically the policy kind of framework piece, the enabling legislation that allows for people to take action in a framework that we all buy into. Things like economic stimulus that will generate new opportunities for new energy economies and other economies that would be derived from this. Critical, because all of these problems are global problems, is the need for international collaboration. And Jim was very, very clear that the United States cannot do this at all, alone. It really requires that international collaboration, if nothing more than the fact that we need global observations of both the atmosphere and the ocean in order to make that a reality, and I see Conrad smiling here at this point. Regional resource planning, the ability for a water resource manager to have a framework in order to plan the release of water from reservoirs in a way that makes sense. I put education in here, education, and I look at Jim Mahoney's family here, and I see these bright young people, and there's a lot of bright young people, and I think that's what gives me so much hope right now for the future is the change, if you will, of what I see in a generation that really wants to do something. We have given them a problem. My generation, the generation before me, has given them a problem, but they have the capability of solving it. They have the tools, and they have just the different mind frame of thinking of it in terms of system thinking that is very different than the reductionist thinking that we had in science when I was growing up. And finally, and critically, Richard Moss, the stakeholder engagement and the decision process in order to really connect with those people who are going to have to make decisions, to give them the information and the tools that they need, and to understand what their needs are. So this diagram, in a sense, is Jim's career, and it's his life. And he's worked with so many areas that is reflected in this diagram. I just had to start off with that. So, but I'm going to talk to you about something that I certainly love. I am an atmospheric scientist, and that I often thought it would be really good for every atmospheric scientist to understand something about the ocean, and every ocean scientist should understand and appreciate the atmosphere. So, and I don't really, what I just did there was rotate the globe and take off all the water on the planet. And it fits into this sphere on the right, and then that top little sphere is all of the fresh water, and then the little tiny dot, which is drawn out of scale a little bit, is all the available fresh water. So, and I put this in there because I don't think people fully grasp. They look at the ocean from a beach, or they look at it from the picture of the blue marble from space, and the ocean looks big. Okay, it covers 2/3 of the planet, and it looks unlimited. Okay, it looks like how could humans absolutely impact this amount of water? But in reality, and I also don't think that they really fully understand how the ocean. I'm talking about the general public. How the ocean really is very, very important to our weather and climate systems. Okay, sometimes we think of the weather. Oh, it's just an atmospheric phenomena. Well, hurricanes are not just an atmospheric phenomena, okay? They're an ocean-atmosphere exchange process. The ocean also, I know it covers 2/3 of the planet, but it's also an average, just 2 kilometers deep. It's the deepest point would swallow Mount Everest with 2 kilometers to spare. It holds the longest mountain range on Earth, the highest waterfall, and the tallest mountain. I already said that. And it is actually the largest habitat on the planet Earth. Nearly 90% of the habitat, the biological habitat, resides in the ocean. So it's really what makes this planet unique. One could question why we call this planet Earth and not planet Ocean. That's been said before. But it is, I think, one of those things that is the reason why we need to protect this very special place. It has it, in spite of what NASA says, in spite of the other oceans that NASA's got to go to, which is good. Okay. When I think of both weather and climate now, I think of this dance between 2 fluids. We have these 2 dominant fluids on this planet, this thin shell of atmospheric fluid, and then there's water that I just showed you in the ocean here. And these two, what here is a sort of an animation. On the left is the ocean currents from a NASA model. And on the right is some satellite imagery of clouds or water vapor. And the idea here is to see, and obviously I've sped up the ocean currents so that they're sort of on the same time scale as the water atmospheric motions. But the idea is you can look at these and you can see, just by visualizing this and looking at this for a while, that yeah, these two are connected. You can kind of see motions occurring in the same places, sort of, you can see the trade winds and you can see the ocean currents going across, and you can see the main Gulf Stream going up along here, and the movement of water vapor. So this dynamic is sort of a dance. I like this call this dance between these two fluids, and this dance between these two fluids is basically controlled or communicated through the air-sea interface that provides the connection of this dance. And this air-sea interface is not just this flat surface, okay? The ocean and atmosphere interface has all of these quantities. It has wind blowing over it, it has breaking waves, it has spray, you have precipitation coming down. It does rain over the ocean, okay? Precipitation, you have downwelling long-wave radiation, upwelling long-wave radiation, you have solar radiation coming in, you get temperature changes, you get these little eddies, turbulent eddies on the front. So this is a very, very complex interface. And trying to model and communicate that interface is really, really one of the major sort of scientific challenges of today. But fundamentally, I put this in yellow here, the fundamental reason that the atmosphere matters to the ocean and the ocean to the atmosphere is that they exchange heat, moisture, momentum, nutrients, and biogeochemical properties. In other words, they are the two fluids that are communicating together and support the life cycle of this planetary system. We've entered the Anthropocene. There's some debate going on exactly when we entered the Anthropocene, but we're here, okay? We are a planetary force on this. It's no longer just the sun and volcanoes and geological formations. It is basically humanity itself. And the fate of human carbon dioxide emissions is shown in this slide. We emit about 9 billion tons of carbon a year, putting it up into the atmosphere, basically through the burning of fossil fuels and deforestation processes. About 46% of that remains in the atmosphere. About 29% of that excess carbon dioxide is uptake by the land biosphere, and then the oceans absorb the other amount. And basically what we're saying here is that humans, this planetary force, is now driving and changing our climate systems. We know that this is an issue because we've seen, this is from the National Climate Assessment, the number of indicators. It's not just a global surface temperature measurement anymore that people looked at initially in the climate change program, but also the temperature over the oceans, the temperature, the decreasing sea ice, the increasing ocean heat content, the temperature over the land that's increasing, the snow cover that's decreasing, glaciers and ice sheets decreasing. And so there's a number of indicators in this warming world. But this is one thing that I hope that we will begin as scientists to communicate more to audiences. It's not just the troposphere or the surface of the ocean, okay, that's going to be impacted. The changes, the warming that we're seeing here associated with carbon dioxide will move into the upper atmosphere. There'll be changes in the stratosphere, perhaps even in the mesosphere, because this is all one connected, the atmosphere is all one connected fluid between its layers, okay, until you get out to the plasma part of the shield around our planet. Likewise, just because you warm the surface of the ocean doesn't mean it's just going to stay on the surface. And through mixing processes over time, basically that heat is going to go into the ocean. And so they go really well beyond that. And these thermal changes that we often talk about, they're actually associated with dynamical changes, both in forcing and circulation responses. And so when you're talking about the science of understanding the climate system, it's not just good enough to look at the thermal properties that you're doing. But really, what are those thermal properties going to be deriving? Because the thermal heating is going to not just uniformly heat our planet and our atmosphere and our oceans. And so you get different gradients, you get different circulation systems, and the entire sort of planetary wind systems and ocean circulation systems are beginning to be questioned. We looked at this last El Nino year. What we knew about El Ninos before didn't necessarily translate this year. Why? Well, there were some additional players in the dance. An extra blob of warm water that was sitting off the coast of California for some time that eventually probably got infused into the tropical system, as well as well, I can't remember what I was going to say there. But anyway, El Nino, how is the El Nino going to change? We thought we knew about it. We thought we could project what it was going to do. What's it going to be like in the future? The other thing that's important is, I like this little cartoon from the New Yorker, where you have this little coffee clutch here, and they're sitting around and say, I don't know why I don't care about the bottom of the ocean, but I don't, okay? The thing is you should, okay? Because the real problem is as that heat goes down into the deep ocean, it stays there for a long time, okay? So even though we see the state of the planet warming in this slide here, where we show here, this is a really good figure that just shows the heat. It's actually showing the warming of the planet. And really, I think is a good example of why the ocean is the flywheel of this physical climate system. So this plot shows over the years here the amount of heat that has gone into the various components of upper ocean, deep ocean, ice, land, atmosphere, and of course there's uncertainty bars there. So you can see here, I think fairly clearly, that the atmosphere is heating up, but it's a very, very tiny fraction of the total heat content. And where is most of that heat going? Into the ocean. And more alarming is that it's not staying just into the upper ocean, but progressing down into the deeper ocean, okay? And so we have a real situation here in the fact that the deep sea, you should care about this, because the deep sea responds to the surface climate on the time scale of decades. But because of the heat capacity of the ocean, the deep sea response lingers for millennia. So already I would say that in spite of the Paris Agreement, we probably have 1.5 to 2 degrees already embedded in our system, our global system of heat. Now, what are some of the circulation changes that are kind of interesting right now? One is the Brewer-Dobson circulation. It is the circulation between the stratosphere and troposphere. It's a sort of a classic model of what we have in terms of exchange between troposphere and stratosphere. It's a very interesting circulation that only could be really observed in the observations through some of the limb scanning or limb imagery from satellites that we've taken. And there have been a number of satellite works that have basically refined and developed this circulation system. And it's really important because it's how water vapor from the troposphere gets intruded into the stratosphere, gets distributed around, and comes back down. The Asian monsoon is involved in some of the forcing functions of this circulation system. But knowledge about how it is changing in this new environment that we are in this Anthropocene era, is still unknown. And there's some indications that it is accelerating. And I really think that this is really an important circulation piece that the scientific community really has to look at in terms of troposphere-stratosphere coupling. But it needs the satellite observations to go along with that. And I would guess that by the year, I think I heard that by the year 2023 or so, certainly within the decade, we may no longer have some of the satellites that we've had in the past to actually get the measurements that would allow us to examine the stratosphere-troposphere coupling. And you need to observe it over decades in order to basically make it interesting or to understand what's going on. The other circulation pattern that I think is really worth looking at, in spite of the greatness of the Pacific, I will focus on the Atlantic. And this is a diagram of the meridional overturning circulation in the North Atlantic. You can see that you have the surface waters in red, the deeper waters in blue, and this complex circulation pattern is what has kept the weather systems that we have across the pond in somewhat balance. It's what keeps the European, particularly UK weather, rather warmer and milder in temperature than what you would expect otherwise. And you notice that right up in the subpolar North Atlantic, there's an awful lot of wiggles in the circulation system. And we don't know a heck of a lot about this at all. Okay, we really don't understand the dynamics of it, what is happening, how it affects the circulation system, how it is going to be changing over time. This black dashed line around 30 degrees in the subtropics has been an array of moorings, an array of instruments that have been collecting data for some time. And I'm really pleased that through international collaboration in the National Science Foundation, there's been a real effort to instrument this very, very complicated sort of circulation period right where the overturning begins up in the North Atlantic. So they're going to have extensive and sustained deployments of moored instruments. They're going to have subsurface floats and gliders, a whole suite of instruments, and includes an international array of partners. Certainly the Europe sector is interested in this, the Scandinavian sector, and as well as China. China's invested in this effort as well. And why am I interested in this, and why do I think this is so critical? If you look at this figure, this is the land and ocean temperature percentiles from NOAA. They do a great job here and always keeping us up to date on these, from January to August of 2015. And you notice that it's red everywhere except in that particular region of the globe. And if you were to take a look at every single climate model and project it out, they would all have red, 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 red everywhere, except over the Erminger Sea there, right where that overturning circulation is. So something is going on there. Either we're not capturing the right processes, or we definitely have some understanding of the ocean-atmosphere coupling that we see here. How does all of this relate? The climate modeling is not the same as a weather forecast, okay? And even if a weather forecast wants to go out to beyond 14 days or over to a subseasonal or seasonal scale, it's not just the atmosphere anymore, okay? In fact, I would say it's probably more likely to have a better chance of a seasonal or subseasonal forecast of the weather by considering what's going to happen to the ocean, because the ocean is going to have a much more dominant impact. But it's not the same as a weather forecast. This is a little cartoon, I thought, and here's the little guy on the left saying, hey, I found the one that does the ocean. It requires that ocean an atmosphere. It requires the land to be in there, the biosphere, actually, because the biosphere is a huge component of cycling carbon and water and nutrients. It has to have the ability to integrate and go out for the computational resources that are immense. And it really needs observations. And I want to stop here for a moment because and just reflect, because this has been something I've learned over my career, I guess, is that lots of people, when they think of science, they think of it as a very deductive process. It's this process that you learn in school from grade 1, you know, hypothesis, and then I design my experiment, and I run my experiment, and that it either verifies my hypothesis or not, and I repeat the loop. When you're studying the planet, whether it's atmosphere or ocean or the geology or the biology, the value of continuous observations in the field is what you have. You have no control. You can't take your information and just go into a laboratory and control the experiment and rerun it many times. You really rely on data, continuous data, high quality data, data that goes on for a long period of time. And that data actually helps often formulate the hypothesis. Okay, and that data also helps to verify or do experiments with that, along with the physical the models. There used to be physical models in my early career days. They're now numerical models. So observational data is just so critical, both in the atmosphere and the ocean. And I can tell you right now that the ocean is much more sparsely sampled than the atmosphere. And I would love at some point to have the ocean at least have half as many instead of the 10% relative to the atmosphere. But, you know, the ocean is much more difficult to get into. You cannot penetrate beyond the ocean's surface through satellites just because the physics isn't there. It's just much harder to actually measure, get the observational data that you need. You do have a tremendous effort that NOAA and many countries have done in putting together the Argo float system. The Argo floats are ready to be upgraded. They can go deeper now, and they can put chemical and biological sensors on them as well as in the future. But the observations are critical for both the atmosphere and the ocean. Let me move on to the policy side. The Paris Agreement, I never thought I'd see it in my lifetime. I was beginning to despair. But the Paris Agreement has been done, and China and the United States have signed on now. And I hope that Europeans will soon, as well as many other countries. And in looking at this Paris Agreement, the ocean is mentioned once. Throughout the entire agreement, the ocean is mentioned once. And it's kind of in the prelude to the agreement. But in looking at the agreement, it's going to provide ways to increase resilience to climate impacts in vulnerable and geographically strategic regions. There's no question about it. It has to use existing tools that must be implemented at national and regional levels, and their efforts must be harnessed to ensure that the ocean is properly reflected in the broader climate change discussions. So this constant sort of need to bring the oceans, the attention to this big program and the problems and the solutions to the problems that we have, the ocean has got to be properly reflected in that discussion. The ocean does play, I hope you understand by now, an important role in the carbon cycle and acts as a carbon sink. And I put here in yellow something that's really, really missing and something that we do not have in the accounting standards or the accounting metrics for the Paris Agreement. And that is that marine ecosystems and species in the open ocean and deep sea, including the corals, the kelp, the plankton, and the marine fauna, they all play a major role in absorbing, moving, and storing carbon. But they are currently not considered or suited to be part of the UN framework on climate change, accounting mechanisms. And this is something that has been pointed out. It's a difficult challenge, but it plays a tremendous significant role. And I would say the development and implementation of the global ocean observing system must move forward fairly quickly. And it is a global international effort that really needs to go forward. I just spent yesterday, I've been on a newly formed, it was an experiment that the Secretary General of the United Nations put together. He put together a science advisory board about 3 years ago. This is the first science advisory board ever in the UN framework that reports directly to the Secretary General. And this Secretary General, if you look at what Ban Ki-moon's legacy has been, and he will be obviously stepping down at the end of this year, all of his three major programs, the Paris Agreement, the Sendai Risk Reduction Framework, and the Sustainable Development Goals. All of those have embraced science and the importance of science in basically affecting change. So I think for many of us serving on this Science Advisory Board, which is an international group of very diverse disciplines, coming together to tackle some of these basic questions of the science, policy, society framework at some of the highest levels of policy, and that is international or global policy. We just met with him yesterday as sort of our final meeting with him, and handed over our last report on the future of scientific advice to the United Nations, and a lot of that advice is basically captured back to this diagram that I talked about before. The stakeholder engagement, the indigenous knowledge that one can use, the pulling together of different knowledge systems, the human interface as well as the physical and chemical and biological environment. The developing of information systems, the idea of big data, the tools that this next generation has to do this science and to make this connection is tremendous, okay? The big data, the capabilities of looking at big data along with model development is immense. The ability to look at system responses, a system, in ways that we could not do 25 years ago is really tremendous. But I do think that there's still lots to be done in our own institutions, and perhaps I can be a little bit bold here in saying what our universities need to do, what the AMS might need to do, what NOAA might need to do, and NCAR. But first and foremost, I hope you get a sense at this point that this is not just an atmospheric phenomena. It may be expressed, the atmosphere may be carrying the message of climate change, but the ocean is the memory. And the ocean, atmosphere, land, human, ice environments, that whole system, this next generation of science is able to actually tackle system science much, much better than I was going to do, just because the tools are there, and the ability to actually probe system-level process questions, such as why is the ice melting so much more quickly than we thought in Greenland? It is a process that is a system process of ice, ocean, warm water, and atmosphere. So understanding those processes from a systems point of view instead of a separate atmosphere point of view, a separate ocean point of view, a separate ice point of view, and then being able to tackle the models and being able to put these new processes in some of our climate models. So I've asked just recently why our new knowledge about an accelerated ice loss associated with warm water coming in through the fjords and shaking loose the grounding points of the glaciers, why hasn't that been able to be incorporated into models? Well, our models have a rigid boundary between the ocean and ice. Okay, so there's no way for the water to flow underneath the ice in order to capture that. These are the things, though, that I find so exciting about this science right now today. The ability to take a look, get the observations, do the process understanding, think about how I'm going to incorporate these into models, and get the observation systems we need. The observations, the other thing that I find so exciting about at least on the ocean side, is the transformation of tools and technologies to get into the ocean. The robotics revolution, the ability for humans to interact with robots in the ocean in ways that are much more agile, flexible, and sort of in real time. The ability to actually do real-time video connections with baud rates that are approaching more realistic than an old phone. These are just technologies that are opening up the ocean to further scientific discoveries. The revolution in omics, the proteomics, the biomics, all of these omics that tell us about life in the ocean and the biological functioning of the ocean and how we can preserve and restore some of that biological functioning in the future. it's just amazing. All it takes is money. I think the will is there, the desire is there, the excitement is there, I would my experience of taking a dive in Elvin to the bottom of the seafloor is something I wish every single person in this audience could have had. It is amazing to just see this world that is such a important part of our planetary system. So I think our research institutions have to embrace system research. They have to understand it. We need our journals to embrace it. We need to have our agencies consider to work on this as well. We need our agencies to think of longer-term funding of research programs. I'm thinking of NSF in particular, but also NASA. Well, NASA does a pretty good job, but NSF in particular. How can you respond when an opportunity comes up in the UK or in Europe of our Horizon 2020 program, which is going to give you a 15-year horizon to tackle the ocean up in the subpolar understanding of the ocean, and not have an equivalent sort of opportunity in the United States to match that, okay? These are important institutional things. I look at Boulder, I live in Boulder now, back home in Boulder, National Center for Atmospheric Research. It's not just an atmospheric research institution. It should not be a center that only focuses on the atmosphere. And quite frankly, it doesn't. Although it does not have the important connections it should have with the oceanography and ocean institutes, as well as the biologists that are needed. UCAR, the University Corporation for Atmospheric Research, there's a wonderful body of 100 university representation consortium, but it's all atmosphere. It's not thinking strategically, moving it forward in this more systems approach. So there are many things that we can do to change our institutions to enable what I consider to be a really exciting time and an important time, and Jim would approve. So thank you very much.
We might have time for one question. So if you'd like to make it a good one, no pressure. Yeah.
Thank you very much for this fantastic lecture. My name is Mahoney. I'm from the University of Maryland. And you mentioned in the big picture the importance of humans and the whole models of the Earth and the ecosystem. And yet, the major models that are used for simulating the future of the planet don't include the key human system variables as dynamic variables. So what is your vision for the future of modeling the humans and the Earth system?
It's a very good question. It's a very, very far-reaching question. It's true that our climate models basically are really emulating the non-human part of our planetary system, other than it being expressed in terms of deforested land. It's expressed in terms of other variables that one can think of. Certainly it's expressed in terms of the carbon emissions that we have. And it does not, as you say, really express it in terms of the population demographics, okay? And it's particularly as you begin to make these models and the information coming from these models and knowledge available to that human populations for adapting to climate change or mitigating climate change. You will need that interface, and you're sitting next to a person right there who understands that perfectly well. And I think that that's one of the wonderful things about that the National Climate Assessment can be doing. In transforming, and we've been talking about this transforming the National Climate Assessment instead of every 4 years big mega project into a number of smaller sustainable assessments that really can bring in perhaps begin to bring in some more of that human dimension. But right now, that human input is expressed through physical, chemical, and biological factors. You are so right.
Susan, thank you again for a really remarkable kickoff to the start of this inaugural series. Okay, now we heard repeatedly that this is the inaugural talk in this memorial series. We've heard repeatedly that Barbara Goldsmith has been both the energy behind and vision behind this first talk, but also going forward. And it's a great pleasure to ask Barbara to say a few remarks about where we go from here. Join me in welcoming and thanking Barbara Goldsmith.
Well, I really have done nothing except I had a good idea and then had some fantastic partnerships with people. The American Meteorological Society, NOAA has been fantastic, both Manson Brown and Carlos has been fabulous, and Susan accepting the moment that we asked her to do this. Everyone has a Jim Mahoney story. Jim was my mentor with a capital M. I first met him at Harvard University, and when I represented the state of Rhode Island in the New England Consortium on Environmental Protection, which was actually the consortium, all the universities in the New England area. So in a way, it's a little bit full circle to what Susan's talking about here, which is how the universities really need to lead the process, and they need to be in front, not behind. I think it's interesting, two things I wanted to comment quickly on. One is the significance of today, the significance of this week. This date that we chose is actually Jim Mahoney's birthday. He would have been 78 years old today. It's less than a year since he passed. We sit today having had our Oceans Conference that Secretary Kerry ran last week. We this week have Climate Week New York City, which has tremendously diverse activities. We have the Clinton Initiative. We have the United Nations meeting for the first time, the General Assembly since the Paris Conference. We have so many issues that are before us that require really creative and futuristic thinking. And when I think about Jim Mahoney, I think he definitely opened up my world internationally. We worked on European things, we worked in Russia, we worked in, way before his time, he was talking to every government of the world on environmental kinds of things. So I think the spirit of this lecture is that we will continue, and Susan has exemplified and personified exactly what Jim would want. And he is looking down on the heavens, and we'll forgive him for the rain today that he wasn't able to control. But really that is the spirit in which this is not keeping up, but really being many, many steps ahead. What do we need to be doing to cope with the very complex science and policy issues, and getting people to think in ways that they haven't thought before. And you have really talked about that beautifully today. So where are we headed? We do have the second lecture, which you'll be hearing more about. It will be held as of now on May 1st, 2017 at the National Academy of Sciences. It will be held in conjunction with the American Meteorological Society Policy Forum. We have not yet selected a speaker, but we do have some possibilities. And so really what we want to do, we've only been able to reach out to a limited set of people, mainly through the National Academy of Sciences, American Meteorological Society, and NOAA. There's lots of people who I haven't contacted. You mentioned Sam Bodman. I've known Sam Bodman since ERT days. He was one of the board members of ERT way, way back. I've lost touch with him. He would be someone we would want to talk about, to let him know that this is going on. So that each of us knows interconnections of people who would be very interested to come to these lectures. And we know that they will be as high quality, and we want to continue having them be very intellectually stimulating in the way that Jim would have wanted it. So it's a beautiful legacy that we're continuing. It is delightful that all the Mahoney family is so well represented here today. I'm tremendously grateful to Conrad Lautenbacher, who immediately jumped in and really facilitated the cooperation and the commitment of NOAA. So everyone has been, so it is, you know, I hate to say it takes a village, and I'm not making a political endorsement, but it is true that it really does take a village, and that's what we've done here. So Bill, if you want to say anything further, the only other comment I would say is that in addition to letting people know about the lecture, we want your ideas. We would be more than happy to have people work with us on nominees for future lectures, on some of the logistical planning. These things don't come together. We're hoping that we can be a little bit more elaborate in our second, third, and fourth, and fifth, and I've already talked to Susan about coming back for the 10th anniversary lecture. So at any rate, it's just a pleasure to have you all here today, and just thanks to everyone who really made this all come together and happen.